Welcome to Chemistry with Dr. D. I'm Dr. D, and in this video, we are going to talk about covalent bonding. So, covalent bonding is when non-metal atoms bond together, they share electrons to make covalent bonds. So, covalent bonds comes from share of electrons, not from transfer of electrons and formation of ions. The electrostatic interaction between the two positively charged nuclei of the two atoms that form the bond and the shared electrons is what makes the covalent bond strong. So the strength of the covalent bond comes from that electrostatic interaction, and that's what keeps the bond intact. So you should remember that only the outer shell electrons are able to be shared or are able to contribute to the covalent bond. So any inner shell electrons will never contribute in making covalent bonds. Each covalent bond comes from a share of one pair of electrons, one from each atom that form the bond. Sometimes atoms need to share more than one pair of electrons. So, for example, when we look at the oxygen molecule, so we know that oxygen is in group 6. That means the outer shell of electrons for oxygen has 6 electrons. In order to reach the full outer shell configuration, it needs 2 extra electrons. That means each atom of the oxygen will share 2 electrons. So we will have now 4 shared electrons or 2 pairs of shared electrons. That means that the number of covalent bonds between the two oxygen atoms is not 1 but 2 because each pair will form one covalent bond. We can find covalent bondings in compound of non-metal elements. Example of that is water. So water has covalent bonding between hydrogen and oxygen, and something like carbon dioxide also comes from covalent bonding between carbon and oxygen. And also we can find it in non-metal elements. For example, we said the halogens, they also come as diatomic molecules, so Cl2, something like Br2, I2, or something like oxygen, nitrogen, and so on. So all of the bonds between the non-metal elements is covalent bonding. So how can we draw the covalent bonding? There are several ways to draw covalent bonding. The first one is the dot and cross diagram. Dot and cross diagram will help us to show the atoms, which atoms the electrons and the covalent bond come from. The electrons are shared, can be drawn using the dot and the cross as one the electrons that come or are shared from one atom is drawn as dots and the other atom is cross, even if both are the same type of atom, but you need to show where the electrons came from. So let's have some examples of diatomic um, um, elements and also for compounds. So let's start off with something like F2. So fluorine, we know that fluorine has 7 electrons in its outer shell. So we're gonna draw 2 fluorine atoms, each one with 7 electrons. So the first one, 1, 2, 3, 4, 5, 6, and then 7. Okay, and then the other fluorine will have 7 electrons as well. The 2 fluorine will share one pair of electron, one from each. So you can draw the second one. You can draw the bond straight away like this. So the second fluorine will have 1, 2, 3, 4, 5, 6, and then the 2 electrons, the shared pair, can be drawn in between these two. When you draw it like this, that means that these 2 electrons here in the middle are actually the shared pair of electrons. So there is one covalent bond between the 2 fluorine. Let's have another example. If we share more than one pair of electrons, so we just talked about oxygen. So again, we're gonna draw 2 oxygens, and remember there will be shared electrons. So to oxygen. Each oxygen has 6 electrons in their outer shell, and they're going to share 2 electrons from each, so 2 pairs. So the first one, I'm going to draw 1, 2, 3, 4, and then 5 and 6. The second oxygen, 1, 2, 3, 4, and then the shared pair as dots. So now, as you can see, there are 4 electron shares, 2 from each atom of oxygen. So there are 2 bonds between the 2 oxygen because there are 2 pairs of electrons. Um, let's have an example of a molecule like water. So we know that water is H2O. That means there is 1 oxygen and 2 hydrogens. So we have 1 oxygen, and for each oxygen will share 1 electron with 1 hydrogen. So the connection between them is that we have 1 oxygen, and then we have 1 hydrogen on one side and another hydrogen on the other side. The hydrogen has only 1 electron and it's going to share it. So the hydrogen is the cross on both sides. And then the oxygen will have 6 electrons, 4 unshared like this, and then 1 shared with each hydrogen. So that means that the oxygen will have 1 covalent bond with 1 hydrogen and another covalent bond with the other hydrogen. So this is how to draw the water molecule. There is another way of drawing covalent bonds, which is called the displayed formula. In displayed formula, the covalent bond is drawn as lines between the electrons. So each line represents 1 pair of electrons, 1 pair of shared electrons like this. So this is ammonia here, and there are ammonia and H3. There are 3 covalent bonds between nitrogen and 3 different hydrogens. So what if we have more than 1 bond between the 2 atoms, something like oxygen? So we know that oxygen is 2 atoms of oxygens with 2 covalent bonds. In this case, you're going to draw them as 2 lines on top of each other. So that means there are 2 covalent bonding between these two. This is useful to show the connection in larger molecules, because when you have larger molecules, it would be difficult to use the dot and cross diagram to represent the covalent bonding. The third way of drawing covalent bonds is the 3D model. So as we can see here in this 3D model, this is for ammonia as well, NH3. So ammonia has 1 nitrogen. This is the blue ball, and then these 3 white ones are, or gray ones, are the hydrogens. So as you can see from the 3D model, it shows the atom, the covalent bonds, and the arrangement in space their arrangement in space next to each other. So it's very useful to visualize the structure of the compound.